What's up, math fans? Today we're doing linear equations. We've been doing linear equations, so I got a little bored. I figure instead of just solving them, now we're going to plot them or graph them on a graph. So you're going to need graph paper for this. Well, it'll definitely help you. Because I don't have graph paper, I'm going to be as neat as possible on my homemade graph. Okay? Also, you notice I wrote here in standard form, and it's standard form for a reason. You can get a story which leads to an equation that's in standard form or not. So let me give you an example in standard form, and then I'll give you one in not standard form. Okay, so think about this story. You have $15 saved in your bank account or your piggy bank or wherever, and you get a job that pays you $10 an hour, okay? So right away you got information that leads to an equation. And you want to know, for example, if you work 6 hours, okay, here's the facts, I'll say them again. You have $15 saved, your job pays you $10 an hour. If you work 6 hours, how much will you have saved? Figure it out before I write it, okay? You can use the pause, All right, $15 is what's considered an initial value. And $10 an hour, that's how much you get paid. That's like your rate, $10 per hour. This is considered, the number 10 is considered your rate. So in most of these linear equation stories, there's always two facts, an initial value and a rate. Depending on the story, it depends how you set it up. This one is as straightforward as I can make it. This X, take a guess what that's going to stand for. If I get $10 per hour, this is going to be the number of hours that you work. And guess what the Y stands for? My total money saved. So to understand what I'm doing, I would make a chart. X and Y. Some people have a bigger chart. Some people make Y equals 10x plus 15 and then Y at the end. If you're quick enough to do it in your head, I only have these two columns. Some people want the middle column to show their work, and some people even make a fourth column, x comma y. Have you seen this before? Yes, you have. It's called a solution to a problem. When I was doing systems of equations with two equations, you were always allowed, our job was to get one solution. Here, you're going to see that you can get many solutions because I only have one equation. When you have two equations, only one solution works. But when you have one equation, infinite solutions work. And what does it depend on? Depends on the independent variable, the x, the number of hours you work. That's independent because you can't stop time. If you work 6 hours, that was my question. So here's the hours, here's the total. And my question was, what if you worked 6 hours? If I work 6 hours, well, my total is 10 times 6 plus 15. And what is that? That's 60 plus 15, that's 75. So if you said 75, you are correct. If I work 6 hours, I have $75 saved. But that was a very specific question, and the point of equations is to establish patterns so you can answer specific questions or not. But this is a pattern, meaning what would happen or what could happen in the future. So just because I said 6, I need you to be able to know what would happen at 5 or 7 or 10 or a million. That's why we have formulas instead of specific numbers. Just to get an idea of what's happening, I'm going to put all the numbers from 0 to 6. So 1, 2, 3, 4, 5, 6. Okay? What if you work 0 hours? Y equals 10 times 0 plus 15. You still got the $15 that you saved. That's my initial value. My first solution is 0, 15. What if you worked 1 hour? 10 times 1 is 10 plus 15. You would have 25 saved. What if you worked 2 hours? 10 times 2 is 20 plus 15 is 35. What if you worked 3 hours? You'd have 45. What if you worked 4 hours? You would have 55. What if you worked 5 hours? You would have 65. What if you worked 6 hours? You'd have 75. And it can go on and on forever depending on how long you work. And all of these are considered 1 comma 25, 2 comma 35, etc., all the way down to 6 comma 75, and all the way down to forever. Those are all called possible solutions. In fact, you could even get crazier because what if you work 2.5 hours? So then I'll have to put in 2.5 here and get another solution. So can you imagine that there's so many different possibilities? How could I show all the possibilities at one time? By graphing a line. I'm sorry, I'm not supposed to tell you it's a line, you figure out it's a line. That's why it's called linear, because when you graph all the solutions, it falls into a beautiful line. Here's an important secret. What's the pattern just by looking at the table? How does 15 jump to 25? How does 25 jump to 35? How does one line, one output, by the way, I used a vocabulary word here, I said this is known as the independent. A lot of vocabulary in this, so you might want to have a graph paper and some vocabulary. Independent variable, x, which makes y the dependent variable. Okay, so my input, also known as independent variable, my output, also known as dependent variable. So how does the output jump from one integer to the next? Let's see. 15 to 25, 25 to 35, 35 to 45, 45 to 55. See, I got a bit of bingo or auctioneer. It goes up by 10. Is that a coincidence that this goes up by 10 each time? No coincidence. 10 is special. What is 10? The rate. Points go up by 10 because the rate is 10. I make $10 an hour, work another hour, make another $10, my money goes up $10. Let's plot this thing. X comma Y, go in alphabetical order. X-axis is horizontal, Y to the sky, okay? So, 0 comma 15. Zero's on the line itself. Don't go anywhere on the x-axis. Go up to 15. Here's a point. I'll do it in red. Next, 0 comma 15. Then comes what? I don't know, I'm in the way, right? 1 comma 25. 1 comma 25 is here. 2 comma 35. See, I don't have to look anymore. I already knew. Memorize the table. 3 comma 45. 4 comma 55. All the way to 6 comma 75. So 6, 75 should be here. Good thing you have graph paper so it comes out even more perfect than that. So get a straight edge so that it comes out even greater than this. Mine's gonna be a little messy. Hopefully yours comes out fantastic. Okay, obviously I cheated because I don't have perfect graph paper, but when you do it, you will see a beautiful line going like this. And this, my starting point, 0, 15 is what? That's the initial value. This line is going up. Do you know why? Because I'm making money. My rate was positive. What else? How is it going up? How is it increasing? Do you know how it's increasing? For every 1 hour that the line goes across, the dot goes up by that number, 10. It goes up 10 and over 1. So from 0 to 15, it went up 10 to 25 and then over 1 to 1 hour. Up 10 to 35 and then over 1 for another hour. Up 10, over 1, up 10, over 1. And these dots could go on forever. That's why I put an arrow here. This line could go on forever. Okay? And guess what? You don't see it, but there's dots in the middle of the dots. You see that dot? What would that dot represent? That's if I worked 1.5 hours or a little bit more than 1 hour, I could easily slide over here and figure out how much I earned. So if I worked 1.5 hours, I'd make about $30. So all the points on the line are all possible solutions. And that's what a line represents, the whole pattern. This is a real life problem, so I started from 0. Hypothetically, if you just got a straight math problem, then the line would go into the negatives. And it will continue going that way. So not only I have an x-intercept, there's another vocabulary word, x-intercept. I would also, now that I have a y-intercept, I also have an x-intercept over here. This point is very, very important. It's called the y-intercept. Where else do you see the y-intercept? It's the initial value. So there's 2 ways to look at that point. That's very important. If you know to start at 15, you could put a dot there. If you know you earn $10 an hour, you know to go up 10 over 1. This is called the rate. And if you talk to the right person, they'll say it's also known as the slope of the line. So once you know the initial value, once you know the y-intercept and you know the slope, you don't even need this table anymore. You can just make the dots right away. Lines quicker. I did it the long way on purpose. You don't need that. And graphing calculator does it. You ever type the button y equals on top? There's a button y equals. You type this in there and it does the table for you. And I'll show you that in a future video if you're curious, or you can just ask me to and I'll do it tomorrow. So what do you need to know here? You need to know my linear equation is in standard form. Standard form means y was alone. Aha, I didn't tell you that earlier. What if y is not alone? What if the story was x plus y equals 10? Y is not alone? Can't do any of this. Can't make the table, can't do the graph. Oh man, there's a trick. But I'm out of time, not gonna do the trick today. Good thing it was not in standard form. That's for another video. All right? So, as long as you have the y-intercept and the slope, you can make any line you want. Thanks for watching. See ya.